Today we're going to learn how the simulation nodes works in Blender with the basic principles. So let's see. First of all, let's do the camera and the light and stay with the cube. Let's go to Geometry Nodes and create a new profile. To use simulation nodes, what we have to do is to bring simulation zone. And to use these nodes, we need to disconnect this and connect the input and the output here. So we have these nodes in the middle of this process. So how this works? As you can see, we have this square of this color that this is called the simulation zone. And basically what does is that any node we insert in the middle of this process is going to affect our object creating animation through the time. As you can see right now, we don't have anything, so if we press play, nothing happens. So let's add something in the middle. For example, a simple transform geometry. And now as you can see, the size and the shape of this zone is changing to tell you, hey, pay attention to this node because it's going to affect anything that you change here is going to affect the animation, the position, the transformation of this object through the time. So pay attention. Now to see something, if we press play, nothing happens. We need to add a change. For example, let's add 1 in X. And let's select this view. So right now, as you can see, the cube already moved 1 meter in X. Why? Because we are in the frame 1. And this simulation zone, it works from the frame 1. What I mean is that if we go to the frame 0, clicking here, you can see that the position of this cube is 0. However, after one frame, it moved 1 meter in X because we have 1 meter here. And if we move one frame more, it moves another meter again. And this process is being repeated every frame. So if we go at the beginning and we make a zoom out and I press play, as you can see, we have already this animation, this simulation. Before we continue, we need to talk about this bar. When we press play in simulation zones, as you can see, it appears this bar. So this bar in the timeline that has the same color as this node is basically the cache. So it's the information of the simulation zone load in your computer. So until we stop, until here, like right now, we can use this cache to go back and preview the animation, as you can see. One really important thing that you have to know is that if you make any change, for example, in this node, in the middle of this bar, without going at the first frame, it's not going to affect to change the animation until it finishes the cache. So, if I press play now, you can see that goes to this velocity, 1 meter by frame. So, if I want to make it faster, for example, I go here and I select 4, in theory, it should go faster. Let's check it. As you can see, the change is not applied because, as I'm saying, this is the cache, the preview of the previous information load. So we are going to see only this change when it finishes the previous cache. So here you will see that goes in a velocity of 1 meter by frame, and after it will go faster. Look at here. 1, 2, 3. So the important thing to remember is that if you do any change in the middle of this bar, it's not going to change the animation. It only changes when you go at the first frame. If I go at the first frame and I change the value, for example, 2, it changes. For example, let's do it again. I'm going to select 3. As you can see, it doesn't change, but if I go at the first frame, because this was at 2 meters, it will start again. So anytime that you want to do a change, really important, go at the beginning, clicking here. Okay, let's continue. Now let's see what is skip. Let me select 1 meter. And basically, skip, as you can see right now, is disabled And when this is disabled, everything is working perfectly. However, when we click here, basically what we're saying is, please skip the simulation zone. So it's like, stop doing any simulation. So to see an example, let's press play. If I click here, it stops. If I click again, it continues. If I click again, it stops. So you get the idea. So we can use this, for example, to create keyframes. What we can do is to say, let's create a keyframe here, right click, and insert keyframe. To see the keyframe, remember, you have to select the object and select this node. And we can say from 0 until 30, let's work. And now let's activate this and let's save the change. So from here to here, it should work, as you can see. And after here, it stops. So we can say, for example, during these frames, let's create another keyframe. Here is skip, so it stops. And now what we can do is move another frame and disable this and create another keyframe. So after this, it will continue. Let's check it. It stops and it continues. So that's all. That's how you can use if you want skip. And remember, if you want to clean this, right click, clear keyframes. And another question is delta time. What the hell is delta time? This is a bit confusing, but basically delta time is one value, so 1 divided by the number of frames by second. So it's like a math operation. So to understand it, let's isolate this with combine. For example, if we select 1 here, it's going every frame 1 meter, right? Let's check it. Okay. However, if we connect this here, it's applying one value every frame per second. But what does it mean that? So let's check it. Now we have, if we go here, we have 24 frames by second. So every 24 frames is going to apply 1 meter. Let's check it. And as you can see, now it's going really, really, really slow. Look. So to do 1 meter, it takes 24 frames. So more or less here, as you can see. 24 frames because it starts at frame 1 to do 1 meter, one value. That's all. Delta time is 1 divided by the number of the frame rate. So if we change this, for example, to 60, it's going to take 60 frames to do one value. Because remember, it's, and let me insist, 1 divided by the number of frames by second. So if we press play, as you can see, it takes 60 frames to do 1 meter. I know it's a bit confusing, and maybe you're thinking, but why is this useful? So basically, this is useful when you want to use a lot of animations and you want to maintain the same values if you change the frame rate. Because if you don't use this and you change the frame rate, the animation, the simulation zone, will change. Because remember, it depends of every frame. So if you want to maintain, I don't know, for example, one animation that is the same for 24 or 60, then you can use delta time. Don't worry if you now don't understand it, but if you see someone using delta time, now you know why. Okay, let's come back to 24 frames per second and hide this, and move it here. And let's delete this. And by the way, remember that you can apply any transformation, not only the position. For example, if I increase this, every frame is going to rotate these values. Or for example, if I increase a little bit this scale, every frame is going to be bigger and bigger and bigger. So remember, it's not only one value, it's all the values that you change. Okay, let's delete this and let's use set position right now because we only want to work with the position. And instead of the cube, let's use points. So let's bring this node and connect it here. Let's come back at the beginning. Remember, you can do Shift left click. And here we have a single point. And let's select, for example, this view. Not this one, this one. And let's select 1 meter by frame. And I have to change the view. Okay, right now, perfect. Actually, let's make it bigger, because if not, we cannot see. As you can see, I'm not seeing the change because I have to come back at the beginning. So remember, when you see something weird, go at the first frame. Okay, so we have a point, like before, moving 1 meter by frame. Now, I want to show you what is happening when we add joint geometry. So, if we add joint geometry, here, it's inside of the simulation zone. So what does it mean that? Look at the difference. If it's here, we only have 1 point, because now we only have 1 point. Actually, you can add more points, for example, 5, and all of the 5 points are being pushed 1 meter every frame. If you want to see the number of points, let's go here, and you can see here that we have 5 points. Okay, now, however, let's come back to 1, and if I disconnect this and connect it here, so now it's inside of this zone. I know it's outside, but the important thing is that this is inside. So every frame is checking again what is here, and is checking the joint geometry, and is adding one of these objects. So if we press play, we have this effect. Every frame is adding 1 point. So this one is the first one that is being pushed, but every frame is adding another point and pushing the next ones. That's why we see this. And as you can see, in 64 frames, we have 64 points. So what you have to know right now is that when we use joint geometry and we add any object, every frame is going to add a copy of this object. So this is really cool, for example, if you want to create particle simulations. Okay, now starts the fun part. Now you can start playing with the position and the forces to create different animations. So we have this one, the basic one. But for example, what you can do is to add a random value here, for example. So if we add here random value in vector, now it's creating a random value for every point. We can define here the range, for example, -6 and 6 positive. And if we press play, it's starting in this random position. However, all the points that are being created every frame have the same position. So how we can do? So every new point that is being added have a different position. We can change the seed. Look, I'm going to do it in real time. If I change this, as you can see, we can change the position. So what we can do to change this every frame is to use a scene time and connect it in frame. So every frame, every new point will have a different position in this range, from 6 to -6 in the 3 axes. So if we press play, we have this really cool animation. And you can make it bigger if you want. For example, let's do it in real time. More. Let me restart again, so you will see it. And you can see it's bigger. So you can play with this to add different values in these points that are being created. This is one option. Another thing you can do is, for example, instead of changing this position, is to do it from here in offset. So let's start again, do not get confused. If we add, let's do it, for example, -1 and 1. If we add a random value here in offset and we press play, let's see what's happening. You can see that we created like a particle emitter. So every frame is moving 1 point in a different direction between this range, as you can see right now. So this is the easiest way to create a particle emitter. Now, if you want to add more particles at the same time, because now it's creating one particle, 1 point every frame, what you can do is to increase this number. So if I add 2, we have more. If I add 3, more. 4. As you can see, now it's creating more and more. I'm going to exaggerate. And now you can see that every frame, for example, if I say 20, and I restart, every frame is adding 20 points. So for example, in 12 frames, we have already 240 points. So this is how you create particles emitters with simulation zone. Now what you can do, let's just select one to not go crazy. I'm going to do this. What you can do, for example, so this is like a cube. What do I mean? Let's select, for example, 0 here. So now if we press play, all the particles, as you can see, is going in this axis. So these 3 directions, right? So it's like this zone because it's the positive one. So this is 0, 0, 0, the minimum, and the maximum is like 1, 1, 1, right? So all the particles are going in this direction, more or less. However, if you want, for example, that goes also to this direction, negative x, we can do is in x select -1. So if we start again, now it's going in this direction, this direction, this direction, and this direction, up. Now, if I want this, but also in this direction, then I need to make negative y. So if we come back at the beginning, now we have an emitter that goes in all directions except negative g, because we have 0. So thing like this is the force, the direction when it's connected in offset. If I want all the particles to go to all directions, then I have to make this -1. So from -1 to 1 positive, and now all the particles are spread in all directions. If you want to make faster or slower the velocity of the particles, the only thing you have to do is to go after random value and add a vector math and select a scale. And with this value, you can increase or decrease this velocity. For example, let's come back at the beginning and decrease this number. Something like this. And now, as you can see, it goes really slow. So if we increase this number, we're increasing the velocity, as you can see. And now they go really, really fast. You can make it faster or slower. What you can do also is to add forces. How? Adding other vector math, for example, a simple add. So now we have this original direction, movement, and we can say, hey, can you add an extra value, for example, in this axis, like 1? And now, let's come back at the beginning, we have one value of forces being pushed in this axis. So we have the random movement, and we have an extra one value in this axis. So that's the result, as you can see. Now the particles go up. You can increase this to make it faster, and it's like a wind. And you can play adding different values to create different forces. Also, what you can do is to use an object to project to create particles. So let's delete this, and I'm going to delete this false, and disconnect this. And basically right now, let's use, for example, a UV sphere. So we have a UV sphere, and right now we don't have anything, any value, any force. So what we can do is to convert this UV sphere in points with, for example, distribute points on faces. So this, what we'll do is to add points on the faces of this object. We can add more points or less. And now, if we want to move this, let's connect this here. And if we come back at the beginning, we have this random animation. However, now these points are not following the normal. Remember that the normals are the arrows, the vectors that are perpendicular to a face. So if this is a face, this is the normal. So if we want to do this, what we have to do is to, for example, get the normal of this object before being converted to points. So to do this, we need to use store name attribute, and to get the normal, we need to use the normal. And really important, remember, a normal is a vector, so here you have to select vector. So this is the same color. And now let's write something, for example, normal, and to use the normal of this object to push these points. Actually, we can delete this for now. To push these points in the normal of the object, then we need to bring name attribute, because we already created a name attribute. So now let's call it normal, and let's use it, for example, here. And now, as you can see, these points, that now we only have original points, we are not adding more points, are being pushed in the normal of this object. So that's how you store the normal of an object, to use it to push the particles, the points, in the normals of any object. As you can see, we can create these explosions. If you want more points, let's come back at the beginning. What you can do is to increase this. Or also what you can do is to increase the size of the original object. So we will have more and more points. Now, for example, if you want to make it smaller, because maybe you want all the points to start from the center, and you will notice that if you make it really small, the points disappear. One little trick you can do, let's select, for example, 1. For example, I want all these points, but I want them to start from the center. So the little trick we have to do is to go here and add a set position, and use, for example, in position, a simple vector math, and select scale. So let's select scale. And with this, we can scale the radius of the points, but it's not working because we need the position. So let's use position. So it knows the reference to scale this, and now we can scale, as you can see, the size of this object without adding more points. Like before, if you do it like this, it's adding more points. So what you can do is to go at the beginning and decrease this a little bit. So for example, you can select 0, and it's working like that. Now you're seeing this because, remember, it starts from the frame 0. So at the frame 0, all the points, we have this number of points, are all concentrated in this single point. And then, the next frame, all of them start to moving in the normal direction of the UV sphere. So we have like an explosion. Now, if you want to do this, but adding more and more particles every frame to create a particle system, then we need to use this, but with a joint geometry, like before. So let's disconnect this, add a joint geometry. Let's connect it here. And let's use all this, but every frame. So every frame, now if we press play, is going to do like before, but adding points every frame. So as you can see, we have this crazy effect. I'm going to decrease the number of particles, for example, 10, and let's see it. So what is happening right now is that, like before, we have an explosion, but every frame we have an explosion. That's why we have these lines, as you can see. We have like a particle system. So how we can do that, but they don't follow the same direction, the normal direction. So how we do that they have a different random normal phase. So to do this, the only thing we have to do is to use all this, but like before, use here as in time, and remember to use frame. So every frame, it will generate points in the faces, but with different positions. So if we come back at the beginning, and if we press play, now we have a particle system creating a lot of points. We can decrease the number of points here. Actually, I want less. And you can see, remember this is the velocity, so you can make it slower. And now we have this particle emitter using an object. Before we were using a random value, but now we're using a UV sphere. And here we can increase the previous size. So the original size, remember. I'm going to press play and add more. So remember, this is the scale of the object, of this UV sphere. Now I'm going to show you how to stop this particle emitter to create particles. So we have already some particles moving, but we don't want to create more particles, more points. So how we can do that? There is different methods to do this, but I'm going to show you the easiest and the fastest, using a simple object like UV sphere. The trick is super easy. The only thing we have to do is to decrease the radius in some moment of the time. So let me change this a bit just to restart the cache, and I'm going to do it in real time. So in real time, I'm going to press play, and in real time, I'm going to decrease the radius to 0. And you will see that the particle emitter is going to stop emitting points. So let me click here to restart the cache, press play, and now I'm going to select 0. And as you can see, we just stopped the particle emitter of creating points. This simple trick. So you can do this creating keyframes. Let's come back at the beginning, select 1, for example, and we can say, for example, create something like until here. Let's insert a keyframe and the next frame. So 41, B0. And let's select insert keyframe. So if we start again, we have this particle emitter that in some point at the frame 40, the radius of the UV sphere is 0, so that means that it cannot add more points in the faces because we don't have any face. So we have a limit number of points, as you can see. There is other methods to do this to stop the particle emitter, for example, adding a boolean when the scene time reaches some point. We can say, please don't use this object, or there is other methods. But for me, this is the easiest and the fastest way. So use this trick if you want to create like an explosion of a lot of points during some time. Now, there is a lot of things you can do with simulation nodes. This tutorial was just to get the principles and to practice a bit. I'm going to do more tutorials about simulation nodes. Some will be really short to show you some little tricks, and others will be more extended to show you more complex simulation nodes that you can do. So if you don't want to miss any of these tutorials, first of all, I recommend you to subscribe to this channel. Second, I'm going to create a new playlist called Simulation Notes, so you can check all the new tutorials that I'm adding in the future to this playlist. And really important, if you like this video, please give a like, and remember, you can download this project and many more and watch exclusive tutorials on my Patreon. And see you in the next video.